Hey everyone, and welcome. Today we are going to crack a fundamental code in math, evaluating algebraic expressions. Now, I know that might sound a little intimidating, but trust me, it's a super straightforward skill once you get the hang of it. So let's just dive right in.
All right, so you see something like this pop up in a math problem. 2x squared minus 5x plus 4. I mean, it kind of looks like a secret message, doesn't it? But what if I told you it's not a secret? It's just a puzzle. And today, we're going to find the keys to unlock this puzzle, and really, any other one just like it. So, here's our game plan. First, we'll figure out what this algebraic puzzle is all about. Then, we'll go over the rules of the game. After that, we'll put it all into practice, maybe up the difficulty a bit, and finally, we'll see why the order we do things in is so important. All right, section 1, the algebraic puzzle. You know, to solve any puzzle, you've got to understand the language it's written in, right? So let's start there and get our terms straight. Okay, first things first, what in the world is an algebraic expression? Well, it's actually pretty simple. It's just a mix of numbers, variables, those letters like n, and your basic operations like adding or multiplying. Think of an expression like 3n plus 1. It's kind of like a fill-in-the-blank sentence. It doesn't really have a final value, not until we know what number n is supposed to be. And that right there leads us to the main event for today, evaluating. This is the key action. It's just the process of taking a variable, like that n or an x, swapping it out for a specific number they give you, and then, well, just doing the math to get a single final answer. It's all about turning that puzzle into a concrete number. Okay, part 2, the rules of the game. So we know what we need to do, but how do we do it? See, to make sure that everyone, and I mean everyone in the entire world gets the exact same answer when they solve the same problem, we need a universal rulebook. And in math, that's called the order of operations.
And here it is. This is our guidebook, the non-negotiable procedure for every single problem. First, you substitute your numbers in for the variables. Then you handle anything inside grouping symbols, like parentheses. After that, it's all about powers and roots. Then you multiply and divide, working from left to right. And last but not least, you add and subtract, again from left to right. This order, it's everything. It's the only way to guarantee you get the right answer. All right, section 3, putting rules into practice. Enough talk about rules, right? Let's actually put them to work. We're going to start with a pretty straightforward example, just to see this whole process in action and, build up a little confidence. Okay, here's our first one. Let's evaluate 50 minus 3x, and we're told that x is equal to 7. All right, let's just walk through our rulebook. Step 1, substitute. We're going to replace that x with a 7, so we get 50 minus 3 times 7. Now what's next? Our rules say multiplication comes way before subtraction, so we have to do 3 times 7 first. That's 21. And now the problem is just 50 minus 21. Super simple. Which gives us 29. And that's our final answer. See, it's not so bad. We just followed the rules step by step and solved the puzzle. That's our first win, right there. Okay, section 4, upping the difficulty. That was a great warm-up. Now that we've got the basic idea down, let's tackle something with a few more, moving parts. This is how we really lock in the skill. Hey, remember this guy from the very beginning? Yeah, 2x squared minus 5x plus 4. It looked pretty complicated then, but now we actually have the tools to figure it out. So let's do it. Let's evaluate it for when x is equal to 7. Okay, step 1, same as before, substitute. We plug in a 7 everywhere we see an x. Now hang on, this is a really key moment. Look at our rulebook. Powers come before multiplication. That's a big one. So we have to deal with that 7 squared first. 7 times 7 is 49. Okay, now we can do the multiplication. 2 times 49 is 98, and 5 times 7 is 35. So our expression simplifies to 98 minus 35 plus 4. And for the last step, we just add and subtract from left to right. 98 minus 35 is 63, and 63 plus 4 is 67. There it is. That puzzle that looked so intimidating at the start, solved. It really is just about following those steps in the right order. So, what happens if we have more than one variable? Does the whole process just fall apart? Nope, not at all. The rules are exactly the same. Let's try this one out. 2a over 5 plus n minus 1 d. We're told a is 40, n is 10, and d is 3. Let's see what happens. All right, you know the drill. Step 1, substitute all those numbers in. Now, our real book tells us to look for grouping symbols, parentheses, and solve those first. So inside the first set, 2 times 40 is 80. In the second set, 10 minus 1 is 9. Okay, much simpler. Now we can do the division and multiplication. 80 divided by 5 is 16, and 9 times 3 is 27. And now all we have to do is add those two results together. And that gives us our final answer, 43. See? Even with 3 different variables thrown at us, the same set of rules led us straight to the one and only correct answer. Okay, for our last section, let's talk about why order matters so much. We're going to zoom in on a really common trip-up spot. This is going to show you why following those rules so precisely is absolutely 100% critical. It's all about the power of parentheses. Just take a look at these two expressions side by side. I mean, they look almost identical, right? But those little parentheses, they make a world of difference. On the left, with 2x squared, those parentheses are like a command. They're telling you to group the 2 and the x together. You have to multiply them first, and then you square the whole result. But on the right, 2x squared, there are no parentheses. So that little squared symbol, it only applies to the thing it's directly touching, the x. You square the x first, and only after that do you multiply by 2. Totally different processes. So let's put this to the test and see that difference in action. For our final problem, we're going to tackle an expression that uses both of these forms right next to each other. Let's evaluate 2x squared minus 2x squared when x equals 4. Okay, let's get to it. First, we plug in 4 for x. Now let's handle the left side, the one with parentheses. We have to do the inside part first. 2 times 4 is 8. Then we square it. Now for the right side, the one without parentheses. Here we do the power first. 4 squared is 16. See the difference? So now our problem is 8 squared minus 2, 16. Let's simplify that. 8 squared is 64, and 2 times 16 is 32. All that's left is one simple subtraction. And we get our final answer, 32. This just shows it perfectly, doesn't it? Those two very similar looking terms gave us completely different numbers. One became 64, the other became 32, and the only difference was the parentheses. That right there is why the order of operations isn't just a suggestion, it's a critical rule. So when you think about it, we've just seen that in algebra, following a precise, specific procedure is the only way to get to the right answer. But this idea goes way, way beyond math class, doesn't it? I mean, think about it. Baking a cake, assembling furniture from a box, even writing computer code. In all of those things, the order of your steps is absolutely everything. What you do first and what you do second, it determines whether you end up with a cake or a mess. It's a pretty powerful lesson, and it's all hidden inside what looks like a simple math problem. Thanks so much for joining me.